All right, let me ask you a question. What could possibly connect these three totally different things? First up, human height.
Then you've got something like standardized test scores. And finally, even something as specific as random measurement errors in a science lab. It sounds like a riddle, right? Well, it turns out they all follow this one beautiful, kind of mysterious shape. You've definitely seen it before. It's the bell curve. Or, its fancier name is the normal distribution. The idea behind it is actually super simple. For a whole bunch of things, most of the results are going to pile up right there in the middle, around the average. And the further you get from that average, the rarer and rarer things become. So let's get into the numbers because this is where it gets really cool. There's this thing called the empirical rule. About 68% of all the data, let's stick with people's heights, is going to fall within what's called one standard deviation of the average. Just think of a standard deviation as one standard size step away from the center. It's the typical amount of variation you'd expect to see.
Okay, now what happens if we take 2 of those steps away from the average in either direction? Boom! You've just captured about 95% of pretty much everyone.
And check this out. If you go out 3 steps, you've got a staggering 99.7% of all the results. We're talking almost everybody. This is exactly why being, say, 7 feet tall is so incredibly rare. You're way, way out there in the skinny little tail of the curve.
Okay, so this shape is clearly important, but that just leads to a bigger question, right? Why? Why is this one shape popping up all over the place? What's the secret ingredient here?
Well, the answer is one of the most powerful and, honestly, beautiful ideas in all of math. It's called the central limit theorem. And this really breaks it down for us. The theorem basically says that if you take a whole bunch of different random independent things and you just add them all together, the result, the sum of all that randomness, will almost always smooth itself out into a perfect bell curve. It's kind of like a statistical magic trick. You pour all this random chaos into the top, and what comes out the bottom is this beautiful, predictable order.
All right, so the bell curve explains a ton. It's everywhere. We get it. But, and this is a huge but, just when you think you've got the master key to understanding the world, there's a massive plot twist. The answer to that question? Not even close. A hard no.
In fact, you could argue that some of the most important things in our world today have nothing to do with the bell curve. I'm talking about things like how wealth is distributed, or how a video goes viral, or even the size of cities. They follow a totally different set of rules. That new pattern is called a power law. And let's just look at them side by side. The bell curve, right? Symmetrical, tidy, and extreme events are super rare. A power law is, well, it's the Wild West. It's all about that long tail, you see, where extreme outcomes aren't just possible, they're kind of expected. And here's the key. Bell curves happen when you add things up. Power laws happen when things multiply. It's all about feedback loops, like the rich get richer.
This quote just nails the difference perfectly. I mean, think about it. If you have 50 people in a room, the average height is a pretty useful number. But if Bill Gates walks into that same room, what happens to the average wealth? It skyrockets. But that new average tells you absolutely nothing useful about anyone else. He breaks the whole concept of average. So what this all comes down to is that we're not living in one statistical reality. We're actually living in 2 completely different worlds at the same time.
On one hand, you've got mediocre Stan. This is the land of the bell curve. It's tame, it's predictable, everything is governed by the average. But then there's Extremistan. This is the wild, chaotic world of power laws. It's driven by networks, growth, and crazy feedback loops. This is the world of wealth, social media fame, and financial markets.
So the big takeaway here, the real secret, isn't just knowing what a bell curve is. The real skill is knowing which world you're playing in at any given time. Because if you get it wrong, the consequences can be massive. If you try to manage a stock portfolio, which lives in wild Extremistan, using the safe logic of the bell curve, you're going to get wiped out. The most important question you can ask yourself is this: know your distribution.